For this module, we are going to complete Chapter 11, Part 1. So on your own, just watch this video on section views and read about orthographic views in this article. We won't read the entire article. Once the section Slanted Surfaces comes up, you can stop reading from there. The reason why I want you to watch this video and read this article is because you will be seeing some section views and orthographic views in Chapter 11, Part 1 and Part 2 next week. So we're going to use all of these different links or files to complete our lecture. So first we're going to just discuss an overview of Chapter 11. So I'm going to open this PDF. Right. And so in this lecture, we're essentially going to be creating a 2D assembly drawing, and we're going to learn how to create blocks. So in more detail, we'll create an assembly drawing from part files. We'll use AutoCAD with the internet, so we'll actually open a file using the internet. We are going to load multiple drawings into a single AutoCAD session, so you can actually work on different drawings at the same time. We're going to learn how to define a block. We're going to create copies of a part using blocks. We're going to learn how to copy and paste using the clipboard. And we're going to reiterate how to use move and rotate commands. So we're first going to discuss what assembly drawings are. It's pretty intuitive, but it is a drawing of the design put together showing the relative positions of the different parts. So if you were to actually, put something together in the user's manual, they'll actually have a picture of all of the parts assembled, how it should look at the end. The assembly drawing is generally done after you create the detailed drawings, so all of the different parts. You can create assembly drawing by tracing the detailed drawings. So basically, well, in AutoCAD, we're not going to trace anything, but we're just going to copy and paste to get these parts into our assembly drawing. And then the assembly drawing can also be drawn from the dimensions of the detailed drawings. This provides a valuable check on the correctness of the detailed drawings. Right. So in more detail, the assembly drawing sometimes gives the overall dimensions and dimensions that can be used to aid the assembly of design. However, many assembly drawings do not need dimensions. An assembly drawing should not be overloaded with detail, particularly hidden detail. Okay, so in our orthographic views of top, front, and right view, a lot of times we'll see those hidden lines. However, in assembly drawing, you don't want to see a bunch of those hidden lines. Unnecessary dash lines or hidden lines should not be used on any drawing. This is even more critical on assembly drawings. So in our example, we're actually going to convert a detailed drawing with hidden lines into a section view drawing. So you'll learn more about that. Right. And then assembly drawings usually have reference letters or numbers designating different parts. So here's a little corner view of what we're actually going to assemble together. Here's one part here, and it has a balloon that's labeled 3. So this would be part 3. And then you have a balloon pointing to this part right here, which is going to be part 2. You can see this is actually another part right here. It's a screw, and that should have a label on it. All right. And these reference letters or numbers are typically enclosed in circles with a leader, so this arrow is the leader, pointing to the part. These numbers are used in connection with the parts list and bill of materials. So usually when you have an assembly drawing, you also have a table on the side showing all the parts, and it'll have, part 1, part 2, part 3, part 4, and then in the table next to part 3, you can have more information on that part. So here is an example of what I was talking about, a bill of materials and parts list. A bill of materials is a table that contains information about the parts within an assembly. The bill of materials can include information such as part names, quantities, costs, vendors, and all other information related to building the part. The parts list, which is used in assembly drawing, is usually a partial list of the associated bill of materials. So in companies, they usually use some type of enterprise resource planning system. A popular one is Oracle's. That's why, Oracle is so, I guess, famous. They have a really popular ERP system that a lot of companies use. And when you're actually creating a bill of materials for enterprise resource planning, you have a lot more information like vendors, contact, exact prices, and stuff like that. It's too much information to put on a detailed drawing. You wouldn't want to see all the information in a user's manual, for example. So this parts list right here is only a partial list of our bill of materials. So we'll have balloons. Or this one has 4 parts: base plate, bearing, collar, and cap screw. And this is actually the exact parts list we are going to recreate next week in the module 8. So you'll create balloons pointing to all of these different parts. This is the quantity. So there's 1 of part 1, 2, and 3, and then 2 of the cap screws. And then this one shows the materials. So that is the parts list. Then we have our drawing sheet borders and revision blocks. So the drawing sheet borders are generally drawn at a distance parallel to the edges of the sheet, typically with distance varying from 0.25 inches to 0.5 inches, okay, from the edges of the sheet. So right here is a revision block. If you were on your layout tab, not your model space, but your layout tab, this would actually be created you draw this 0.25 inches to 0.5 inches away from this would be like the edge of the sheet of paper, okay? And this will show revisions, like the date you revised something, if it was approved, the description of what you revised. And then once a drawing has been released to the shop, any alterations or changes should be recorded on the drawing, and new prints be issued to the production facility. Again, this is in the upper right corner of a working drawing sheet. Okay. And yep, this is an example of the revision block. Then we have title blocks. Let's see here. So title block, or the title of a working drawing, is usually placed in the lower right corner of the sheet. The spacing and arrangement of the space depends on the information to be given. In general, the title of a working drawing should contain the following information. So in a title block, you'll usually see the name of a company and its location, the name of the part represented. So if just one name, not all of the parts. So in our example, we're creating a shaft assembly. So that's what the name of the part would be. The signature of the person who made the drawing and the date. So you always want the designer and when it was, completed. Signature of the checker and the date of completion. So you always have at least one person, checking to make sure your drawing is completed correctly, for quality assurance and quality control. Then you'll usually see the signature of approving personnel and the date of approval. So usually this is some type of manager or certified engineer that will actually approve your drawing. You'll see the scale of the drawing. This is very important, as we've discussed previously. You want to make sure that if somebody were to measure your actual drawing, it would be scaled correctly so that they can, recreate it. Like if they were, building a mold or something, or an easier example would be a house. If you were in construction and you had the drawing on a, sheet of paper, a large sheet of paper, you'd want them to be able to measure the sheet of paper and measure it correctly based on what your scale is. And then your drawing number, most parts and assemblies, they all have numbers, and so that's usually defined by the company. There's different ways to actually number, you know, your parts and assemblies and things like that. All right, and then other information could be like material, heat treatment, finishes, hardness, general tolerances. It really just depends on the company and what the design is. All right, so here is an example of a drawing. So here is our assembly view right here, and then we have some parts right here with dimensions with more detail. So here's the shaft, here's a bushing, nut, and washer, okay? So I'm sorry, this is not actually the assembly drawing, this is just the shaft, that's a part. Anyways, you can see that here's a parts list. So we have 4, and we have 4 washer there. So this is a little different than what we're gonna do because we're creating an assembly drawing. But you can kind of see here is the parts list, and then here is the title block right here with the drawing title, the size of this sheet of paper. So just normal printer paper is, you know, just A4 printer paper. And then you'll have your drawing number, and you can see they have some tolerances and things like that they put as well. So in our example, we are actually going to create this shaft support assembly. Here is a 3D view. In this class, we're only doing 2D, so you actually won't, it will look different than this, but we're going to draw a 2D assembly drawing from a front view of this. So we'll see, you know, the front view of this part, the front view of this, the front view of these 2 screws, and the front view of this part here. All right. So I'm going to switch over to the instructions here. I just want to note that this lecture actually goes through the, you know, the inserting table, parts list, and things like that. And we are actually not going to do that in M7 module. We're going to do that in the next module. So now if you go to these written instructions, open that. All right. And then this will actually give you written instructions. We're going to follow these. However, I'm actually going to do it with you, and I'm going to show or share my AutoCAD screen with you. So I'm actually going to move these down. However, if you prefer, you know, written instructions over the video, you can absolutely use these written instructions. All right. So the first thing we want to do is we actually want to open these 2 DWG files here. So I'm just going to right click, and I'm going to do save target as. Okay. I'm going to go to my desktop, and I'll just click up here, new folder. I'm just going to put it in 1309, chapter 11 lecture. All right. And then I'm just going to put my base plate in there. You can save this wherever you want. So, right. And then I'm going to save this target as, okay, let's see here. We're gonna, it's the right place, so we'll push save. All right. And then it's also, I wanna note that there are some extra steps in the PDF that aren't in the book. So we follow the book pretty much. However, there's some labs that aren't gonna follow the book. So make sure that you use the PDF instructions for the labs. However, you can use your book as an extra resource. So, you know, there's just some differences, mostly the same, but you'll see once you get into the labs. Okay. So I'm gonna open the folder with all of my things. Okay, so I have those 2. I'm gonna go to AutoCAD, and I'm gonna go to open. And then I saved it under my desktop, 1309 chapter 11. And then I'm just gonna hold shift and click on both of these and then click open. You can open them one by one if that's easier for you. All right. And then we actually have to open a CapScrew file. So if you look at the instructions here, there is this link right here, and I'm going to, let's see, allow. Okay, so it's pulling up a website with this. We're going to use a different method, so I'm going to do cancel. I'm going to go back here. Ooh, sorry about that. All right, so I'm going to right click and do copy link location. Okay, so basically you just want to copy and paste this. That's what you're trying to do here. Okay, so copy that, and then you're going to go to AutoCAD and click open. And then in this file name, you're just going to do Control V to paste that website link, okay? And then click open. All right, and here's the CapScrew. So just so you know, in AutoCAD, you can actually open files from the internet as well. And so that you just put the web link in the file name area and it'll open it, which is pretty cool. So I'm going to move the instructions down here or to my other monitor. All right, so they're not in the way. And then we are actually going to rearrange the windows so that you can see all of your different like drawings at one time and work on them at the same time. And so to do that, make sure your menu bar is open. If it's not, remember, click this little arrow, then click show menu bar. Mine's open, so it says hide menu bar. And then you're going to go to window. You're going to go to, let's see here, tile horizontally. Whoops. Yep. Okay. So here we go. You can see these three there. Okay. And yep. All right. And then we are actually going to maximize the CapScrew though. So I was just showing you how to do that, but we're not actually going to do anything like this. I just wanted to show you the capability that you can. Okay. So I'm going to open the CapScrew now. And then we want to switch off all the layers in this design except the object lines and the center lines. So we'll just go here and we'll turn everything off. We want to turn off our dimensions, our depth points. So always see our object lines, which are the blue lines, and our center line. And then we want to actually, let's see here. All right, now we're going to actually create a block. So we are going to go to create. All right. And then we are going to, we're going to call this the CapScrew. All right. And then for the picking the point, we're going to click this pick point, pick base point. And we're going to pick this point right here. Make sure your intersection object snap is on. So mine's on right there, as you can see. So just click that point. That's going to be our base point, which is if when we paste this block or put this block of the CapScrew somewhere else, that will be the point we can move the CapScrew around. So you'll see. And then for this objects, we want to make sure it's retain. Okay. So for this object right here, we want it to retain as the individual lines and everything. We don't actually want it to be a block. We're just creating a block based on, you know, these different objects. And then for behavior, we want to allow exploding. So when you have a block, you can actually explode the block to, you know, change things and stuff like that. So we want to be able to do that for this cap screw. And then the last thing we need to do is actually select our objects. I forgot about that. So we're going to click select objects right here. And then I'm going to click once to do a selection box, and then click again, and then hit enter on my keyboard. And you can see that there are 29 objects selected. And you can also see a little preview of all the objects in this little icon or picture right there. All right. So then after you are done with that, we are going to click OK. And now we created our block. You can see that nothing has really changed so far. You know, this is still all of the individual lines. So now we're actually going to insert the block. Okay, so it's very easy. All you're going to do is click insert, cap screw. So click on that. And then we are going to we want to rotate this. So we're going to go down in the command prompt and click rotate. Our angle, we want it to be, we want it to go to the right, 90 degrees. And so remember, it's counterclockwise. So this is 0, 90, 180, or plus 90, and so forth. So we want it to go 90 degrees this way, which is negative. So we're going to do negative 90. Then enter. All right. And then I'm just going to just click to actually place the block down. You can see that when I click on this, this is all one block now, whereas this is all of the individual entities. Okay, and now that we have our parts here, we are going to create our assembly. So we are going to go to, we're going to create a new assembly drawing, and we're going to use one of the AutoCAD templates. So we'll go to new. Okay, and then so far we've been using this start from scratch. This time we're going to use a template, and we are going to use the one that's this top one, ACAD name plot styles.dwg, the very top one, and it has a description. So this is using feet and inches, okay, and has different ways that you can actually plot, defined ways you can print, essentially, plot your design. So I'm going to click OK. All right, and then I'm going to go down to my status bar, and I'm going to turn the grid off. All right, and then I am going to, let's see here. I am going to go to my, or I'm going to save this. So I'm going to do save as, and you can save it, wherever you want. And you're going to save it your username _ shaft assembly. And also for one of your labs, you are going to submit the shaft assembly with one more part you're going to draw. So make sure that you actually save what we're doing. Okay, so save that. Right. And now we are going to add the base plate, the front view of the base plate to our assembly. So we're going to go to base plate. We are going to, let's see here, select, so click and then click. So select all of the front view. So this is the front view, the top view, and the side view of the base plate. We're going to hit Control-C on our keyboard, and then we're going to go to shaft assembly, and we are just going to do Control-V and paste this, just click to place it or paste it into your shaft assembly, okay? Again, I just did Control V and then clicked to place it in the drawing. So right now, this is the orthographic view. Again, for assembly drawings, we do not want to add those hidden lines there, okay? So we're actually going to convert this view into a section view. To do that, we're going to right click on our screen and then hit Quick Select. Quick Select is a really amazing tool because say you have a lot of different parts on your drawing and you want to only select a specific layer, or you just want to select all of your dimensions or something like that. You can use Quick Select to actually select all of them for you without having to click on each one. So right now we want to actually change all of our hidden lines into object lines. So we want it to apply to the entire drawing. The object type, we're going to use multiple object types, okay? We're going to go to our layer, and we want our layer to equal this hidden line. So basically by its Quick Select, it's going to select all of everything in the hidden line layer. And we want to include in a new selection set. I mean, you can also exclude something from a selection set, okay? But we're going to include it, click OK, and it selects all of our hidden lines for us. I don't know why that popped up there. Anyways, we're going to go here and click Object Lines, okay? And we just changed all those hidden lines to object lines. I'm going to hit Escape. All right. And then we have that completed. The next thing we're going to do is we're going to add hatches to make this an actual section view. So just like we were to cut, something in half, or this base plate in half, the parts that don't have a hatch are going to be the holes. Okay. So I'm going to make sure it's on my object lines layer. I'm going to click this icon here, which is hatch. And then I'm going to go in and I'm just going to click, oh, I don't know why this keeps popping up, but anyways, okay. Click there, click there, click there, there. All right, and then we are going to do click Close Hatch Creation. All right. And there we go. We just converted this view to this front view into a section view. So again, this is all the hard surfaces if you were to cut something in half, and these are all the holes. I'm just going to save this really quickly. I think that might be causing me some issues here. So I'm going to do File, Save As. I'll save this in the same location. This is the cap screw. Okay. Just going to call it cap screw, and then save. All right. Awesome. So now we are going to add our bearing to our assembly drawing. Okay. So this one's already in a section view. You can see that they cut, this part in half right here with these arrows. Okay. And here is, once you cut it in half, this is what you can see from the side. Okay. This is the top of the bearing, and this would be the side view of the bearing. Let's see here. So we are going to use a selection window, click once, and then click again. And then we're going to right click, and we're going to do clipboard, copy with base point. We're going to have our base point right here. Okay. This is actually, when we paste this into our assembly drawing, we're going to paste it with that point right there. Okay. And then we are going to go to our shaft assembly. All right, and we're gonna go to edit, paste as block. Okay, so we copied with the base point and we're gonna paste this as a block instead of all of those individual lines. So we're gonna do paste as block, and then we're gonna go right here and click to paste. And you can see, because I pasted as a block, it's all one entity now. And then if you go to insert, you can actually see it automatically created a block for that part right there, okay? So, all right, now we need to rotate this 90 degrees. So we'll go to rotate. I already had this selected. And then I'm gonna click this point, the base point right here, because we want that to stay stationary, okay? And then I kind of just like to turn my ortho mode on and then move my mouse down here and then click. Okay, awesome. So now this part is assembled correctly. And you want to make sure that everything matches up. So you want to make sure these center lines match up, you know, everything's on top of each other. This is how it should be if it was actually assembled together. All right. And then we are going to add the cap screw, excuse me. So we are going to do the same exact thing, but we're going to learn, you know, the shortcut for doing the copy and paste as block. So we're going to do a selection window. So select this, and on your keyboard, hit Control-Shift-V. Oh, sorry, escape. Click escape. I mean Control-Shift-C. So do a selection window, then Control-Shift-C, and I'm just going to use this point right here as my base point. You can use different ones. Okay. Then I'm going to go to my shaft assembly and do Control-Shift-V, and a Control-Shift-V allows us to actually insert this as a block, okay? Control-V will only insert this not as a block, just as all of the individual entities. Then I'm going to place this right there at the intersection where the center lines match up, and the cap screw, the top is, you know, lying on top of this. And then we're going to do Control-Shift-V again, and then place the other one over here. All right. And so your design should look like this. In the next lab, or in the first lab, you are going to actually draw the collar and then add the collar to this drawing yourself. Okay, so this is all the parts except one, but you're going to actually complete this assembly in the labs for this module.